Hello everyone, this is the video lecture for Calculus 2, section 11.3, multiple choice guessing. Integral testing. That was just a joke. So as we keep going through the rest of the chapter, a lot of times you're going to see a lot of questions that say converge or diverge, and you click one and it says yay, or it says no. Then you click the other one and it says yay. And you can basically get 100% on your homework, or at least a 70 at least, without doing anything. You just simply click, 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 and you get the right answers eventually. That could even work possibly on quizzes, but I don't think the quizzes are tailored to something like that. It will not work on an exam, and it defeats the purpose of the class. So we're going to learn this stuff, even though it's going to be sometimes easy to do the homework. It doesn't necessarily mean the math is easy or if that's a good idea, okay? So we still need to go through this. This is very important. So integral test is just another test. And in fact, I would recommend before going on, get the formula sheet book thing. There's a formula book in Blackboard where you could just download it, and in the Calculus 2 section, they have all of these tests in one sheet. It's one piece of paper, geometric, telescoping, P-series, all this kind of stuff here. Get that, hang on to it. I know that it's not something you can technically have during the exam, but you can write some of those on a note card, at least, and so at least some of the more common ones. I don't think we use every single one every time. The idea, though, is that there's a lot of information already done for you. You just need to follow the directions, and it's super easy. So let's go through some of these, and then we'll get to this integral test thing. So geometric, we've already seen this thing. If you see this format, it's a sub 1 over 1 minus r, and that's your answer. You're done. Converging, diverging, depending on your r. If its absolute value is less than 1, then it's converging. If the absolute value is greater than or equal to 1, again, just like the number's bigger than 1, then it's going to diverge. So we've already seen that. Telescoping, we did that one as well. So if you see this format where you have something minus something else and they're really similar to one another, the answer, your S, your sum, is going to be the first term minus L. And if you noticed, that was going back to the last problems that we did in the last section. L turned out to be 0 on one of them, but it actually turned out to be a 1 in the other problem. So we actually have to find out what that limit is. Converges if your limit of these guys will go to a number, that is L, or 0 or 1 or some kind of number, okay? So converges that way. Notice that I don't say what makes it diverge, and that's kind of ambiguous, and that's okay. So sometimes on these tests you'll see, well, it converges if you do this, and then they'll just let it go. Well, does that mean that it diverges if it doesn't converge? I mean, that's normally what I'm taught, right? I don't think that applies with these tests, because if it doesn't meet this criteria here, then maybe there's a different test that might work. And so I wouldn't just jump to the conclusion automatically that one test will solve it all. You might have to use 2 or 3, kind of depending on what's going on. P-series is another one that we've already seen. Again, the bottom right here, we're looking at its power. If it's greater than 1, you're good to go. Like, I'm serious, 1.01 will work, but 1.00 is not going to work, okay? Anything 1 or less will diverge, okay? Cool. So, integral test. I already wrote it. See, isn't that nice? So, integral test. If you see some kind of series, you can always do integral test. If you integrate from 1 to infinity and that integral converges, then it converges. If that integral diverges, then it diverges. So the series is tied and linked to the integral. And notice, isn't that the same thing here and here? I got S in Greek, and then I got S in Latin. I got summation, and I've got integration. They're the same thing. They're the same thing. So I'm saying, hey, what about this summation here? We'll just do it in calculus-y land, and then all of a sudden you got the same exact thing, okay? There is one extra stipulation which we'll use, I think, at the very last problem. This remainder at some n is always going to be between 0 and the integral of n and outwards. I will remind you about this guy right now. I wouldn't worry. Integral test is basically if you see something, you can integrate it, and if it works, it works. If it doesn't, it doesn't. That's it. The end. So 11, 3, 0, 1, 9. So I've got summation, I almost said integral, summation of n equals 1 to infinity of n over n squared plus 16. And I want to know, does this converge or does it diverge? And I can tell you immediately that it diverges. I don't have to do an integral. I don't. I will. I will do an integral, but I don't have to do any integrals. You don't have to do any integrals if you don't want to. Notice that plus 16, he's so tiny in comparison to an n squared. Well, n over n squared, I guess you can cancel those guys a little bit. Say it's 1 over n. And oh my goodness, it's p series. And notice that this is a 1, so it's going to diverge. 1 or less will diverge. If it's a 2 or something, then it will converge. So that was it. Notice that in the integral test section, I just used p series. And that is okay. I hope that you're going to keep doing that. Don't get stuck on it like, oh, I have to do integral tests because of whatever. Your quiz is not going to tell you that. Your test is not going to say, blah, 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 this is from the integral test section. Do what you got to do. You're done. You're done with this problem. But what I want to do is that this is a nice, easy problem to test out this integral test, to show you what it looks like, and then we'll move on. But don't just do the one thing that they always tell you to do. Later on, they're going to do ratio and root tests and stuff. Those are pretty important. But do you have to do them every time? No. All right. That was just my piece of advice. So let's actually do this. I'm saying that this guy is linked to my integral. They're nearly one and the same. And so if my integral works, then my summation works. If my integral doesn't work, then my summation won't work. That kind of thing. So I want to be able to integrate this guy, and it's actually not too bad. I'm going to do some u substitution. In fact, who's using n's nowadays? Can we just use x? Is that okay? Right? I like the x. X is so much easier. So u is going to be equal to my denominator, du, 2x dx. dx is du over 2x. Use those two guys. So integral from 1 to infinity of x over u du over 2x. The x's cancel. The half comes to the front. What's your integral of 1 over u? It's going to be ln of u. Actually, whoa, I messed up one thing. Did you see it? Right here. Actually, I don't want to do that. I want to say this. X equals, x equals, x equals, x equals. So again here, x equals 1. X equals infinity. Yes, I make mistakes too. It's okay. So then I'm going to replug that in. And now I can say it's 1 to infinity. And now I plug it in. I plug in both of these terms. And so I got 1/2 ln of infinity squared plus 16, and then minus 1/2 ln of 1 squared plus the 16. So notice here that I got, basically here this is infinity. Infinity squared plus 16 is definitely an infinity. What's ln of infinity? Is infinity. That's right. So infinity minus, and what is this guy here? He's a number. I don't know. He's just a number. I know some people say hashtag, but it's a pound sign or just a number. So I got infinity minus a number. And so we got the richest man in the whole wide world. I'm just going to say Bill Gates because I don't know if that's true or not. But we got Bill Gates, super rich. And then he says, hey, Bill, you owe me $100, bro. And he's like, you're wasting my time. Here, have $1,000. I don't really care. He's still going to have infinity. And so therefore, your answer to this integral is infinity. What does that mean? It means that it diverges. In the end, done. That was it. So we can integrate and get the same results, or we could do something else. All right. 11,3,0,11. I have summation n equals 1 to infinity of 1 over n to the square root of 7. And they say converge, diverge. Which one is it going to be? And I'm going to tell you that this guy converges. And that's it, the end. Well, how? This is P series yet again. Notice that my P here is the square root of 7, which is more than 1. That's a 7 in there, okay? I don't know what the square root of 7 is, but I know that the square root of 4 is 2, and the square root of 9 is a 3. So it's definitely more than 1. Converges. And you move on. You don't have to do the integral. Now, I did the integral for this one. I did a whole big page on this thing. And I'm looking at it, between you and me, I don't see the need to do it. I don't see the need to do this integral. I'll give you a couple steps, okay, just so that I could say I did it, okay? But the point, yes, is yes, we're doing integral tests, but we're doing integral tests when we need to do integral tests. We haven't actually encountered that yet. We will have to eventually, just not yet. So I'm going to integrate this guy. Don't overthink it. It's honestly just going to be a negative square root 7 in the power. I know that it looks intimidating, but it really is not. I'm going to add 1 to the power and divide by that new power. This is not hard. And then from 1 to infinity. And so when you start plugging things in, what you actually have in the front is this crazy little number times, and then 1 over x to the, and this guy is going to be really weird, square root of 7 minus 1, something like that. Again, from 1 to infinity. When you plug in the infinity into x and the 1, what you're going to get here is still infinity. So basically some kind of number, and then you got 1 over infinity, and then it was a negative, so maybe a positive now. And then you plug in the 1, you get like a 1. You got some kind of number out here. Well, this guy's a 0. 1 over infinity is a 0, plus a number is a number, converges. Now, you might be wondering, well, isn't it important to know what that actual number is? Because that's the answer, isn't it? When I take my integral, I would get my answer. Wait, is that the answer to your summation? Like your actual, remember how you had this guy here? Are the integral and the summation, are they equal? Are they literally equal to one another? The answer is no, they are not equal to one another. They are similar. They are very close. I would say if you want a good rough estimate, that would be a great idea, but they're not the same. Let's demonstrate. Let's say that I had some kind of curve, and I said, okay, find the area from here to there. Okay, well then wouldn't I just integrate? But what if I had to use a summation, and that means little rectangles, right? Little rectangles. And I do that. Will my rectangles, my discrete values, like this right here, this is at 1, 2, 3, so on and so forth, 4. If I took these rectangles, will I get the exact same answer as my integral? No. You'll get something close, but you won't get the exact same answer. There'll be an error. There'll be a remainder. And that's why they have that RN thing that we talked about a little earlier. All right. 11,3,0,13. So they give me this series 1 plus 1 over 16 plus 1 over 81 plus 1 over 256 plus, and they say, hey, does this thing here converge or diverge? Now, I don't actually know. I'm looking at this guy and I'm thinking, oh, it's diverging. Well, I don't really know. We have to do the math here. What I actually want to do is rewrite this as an understanding. Couldn't I say that this right here is it 4 squared, 4 times 4? And no. I got a better idea. Yeah, 4 squared, 4 times 4. What about 2 to the 4th? 2 times 2 times 2 times 2. Is that going to work? And this is 3 to the 4th. And this is 4 to the 4th. And so what I'm doing is I'm saying this is a summation of 1 over n to the 4th. Converge or diverge. And that converges due to P series. Look at that 4 right there. Converges all day long. That was it. I guess you could say P is greater than 1. Done. 11,3017. Summation n equals 1 to infinity of the square root of n plus 8 all divided by n squared. Converge or diverge? I'm going to wait for a second. What do you think? It's converge. Yep. I did not do the integral at all. I don't need to do no integral here. I'm doing a comparison. I'm going to say, hey, you know what? This is pretty close to this guy here. And if I were to simplify this, that's n to the 1/2, and that's n to the -2. And I can combine I'm multiplying their bases, so I add their powers, so I get -3/2. And I can rewrite that in the bottom. Oh my goodness, it's P series again. Notice my power is 3/2. 3/2, is it greater than 1? Yep, converge. That's it. Pretty easy. I mean, are you doing an integral like ever? Actually, no. I haven't yet. I haven't really found a use yet. So I've got summation of n equals 3 to infinity of 8n minus 12 divided by n squared minus 2n. And again, does this converge or diverge? I'm trying not to look at my notes when I do this stuff. I think that this one is going to diverge. Pretty sure. So let me show you why. I'm going to do a comparison here. Notice I have this minus 12. That's so inconsequential. What I have is an 8n, and the bottom here, what I would rather you see is just the n squared. So I have an n squared, and I got a 2n, and so you can plug in 1,000 or whatever. 1,000 squared is huge, huge, huge. And then you're saying, well, minus 2 of those guys. Just imagine you got like 1,000 of these little lines here. I cannot draw 1,000 of them, okay? I got 1,000 lines, okay? Here, I'm just making, it's good enough. And then I say, okay, well, just get rid of 2 of them. I mean, you got a lot left. And that's why this minus 2 business is inconsequential. It doesn't really help. It doesn't really change anything. So I'm just going to go to n squared, and it'll be okay. Well, you can already see also that I can cancel an n in both the top and the bottom, right? And so look at this guy. He's P series again. And again, and again, and again. But now, converge or diverge, this is a 1 power right here. You see that? That's a 1 power. And because P is equal to 1, it's actually diverging. It's the very last number that diverges. Okay, 1 still diverges, but 1.01, that would converge. I have a little note here. It says, hey, they want you to use integral test, but, and I just didn't do it. Okay. I mean, it's not hard. It's not rocket science here. So I've got summation n equals 2 to infinity of 8 over n times ln of n. And they say, does this converge or does this diverge? And I'm going to say this diverges all day long. And it's so easy to see as long as you're seeing what you need to see. Now, what I'm going to do is I'm going to do the integral test this one time. I will do it. I've got to do it at some point. So I'm going to do the integral test right now, just so that I feel like I'm doing a good math professor-y kind of thing, okay? But then I'm going to tell you why it's diverging a lot easier, and then we'll be done with this problem. So I'm going to integrate this thing. Because it starts at 2, you get to start your integral at 2. So that's pretty easy here. Gosh, let me just use x's. X's are going to be way easier. Okay, so we got x's instead of n's, whatever. What I want to do is u is equal to ln x du is going to be 1 over x dx. And I'm just going to leave it just like that, because what's going to happen is that you have this x right here, and then you got a u now, and then, well, dx. Well, notice that this is 8 times 1, and so these guys here and this guy are right there. And so you can rewrite it now as 8 over u du, and you're done. In a way, you could also go the extra step, x du, cancel and stuff. That's fine too. But I just wanted to say, like, you can look at it and say, well, there you go. Again, this is x equals 2 to x equals infinity. Please remember to do that. Well, when I integrate, I'm going to get 8 ln of u. And so then I plug back in my x's, which would be, is it ln of ln? Hold on. Actually, I did something really bad on my notes. I skipped this step. Well, doesn't really matter because it's going to end up being the same thing. This was a bad step right there, man. It's ln of infinity. Okay. Whatever. Sometimes my notes aren't perfect, but hey, at least we get them right together. So ln of x, and from now 2 to infinity. Awesome. So I plug in the infinity, plug in the 2. So what I've got is 8 ln of infinity, blah, blah, blah. Well, ln of infinity is infinity, blah, blah, blah. And ln of infinity is infinity, blah, blah, blah. And so 8 times infinity is going to be infinity. And you can see the answer then is diverge. Okay. Cool. So we did the integral test. Yay! For like once, kind of. Yeah, that was fun. So can I tell you why I knew it was diverging way ahead of time? Please. Oh, yes, of course. If you're looking at this guy, let me just rewrite him. I've got 8 n ln n. Okay. 2 to infinity. It's whatever. Okay. So I see 2 different portions down here. I see this guy right here, which is basically summation of 1 over n. And I see this guy here. I'm going to put an and sign to make it totally unofficial. Okay. This one right here, they say, hey, is that converging, diverging? I don't really know, but I do know that this one here is diverging. Okay, do the P series and stuff like that. So I go and pull out my cool, nifty comparison chart thing, and this is more of an abbreviated version. Yes. Okay, that's good enough. Remember that guy? Super important. So there is this right around here where we start to converge or diverge, that kind of thing, as long as it's in the denominator. Well, I'm going to ask, summation of 1 over x squared, is that converging or diverging? So this is converging because of the power of 2. So basically, like from here and this way, we got converging, folks. And then from here, this is 1, so he's like the first one that's diverging. From here back, we have diverges. So if these guys are in your denominator, you're going to diverge. Here's a good example. This square root here, isn't that a 1/2 power? So it's 1/2. Is that going to be converging or diverging? That's diverging because that's less than 1. And so right here we got diverging. But we got ln in the bottom. He's part of the diverges as well. And so I got diverges and diverges. Yeah, guess what? It diverges. Now, this wouldn't hold as true if I had one diverges and one converges. I would definitely have to go and look at that one, because would one weigh more than another? So don't always just use this super quick way. I mean, I think it's a good thing. If you got diverges and diverges, then clearly it's going to diverge. You got no other options. But if you have opposites, then I would start to give it a second opinion, I guess. And we will do that eventually. Next problem. So I got n equals 2 to infinity of 9. I think it's a 9. It might be an A. I can't ever tell my own handwriting. 9A, whatever, it doesn't matter. N, ln of n, all to the p power. Okay. And what they're asking about here is they're saying what values of p are going to make it converge. Okay. I want this guy to converge. What values of p are going to make it work? You know what's funny? Scroll back up. Scroll, scroll, scroll. Scroll, scroll, scroll. Scroll, scroll, scroll. Look right there. And we said that guy diverges. Down, down, down. Down, down, down. Down, down. Ooh. What about this guy? Look how similar. So yeah, you pulled a 9 to the front. Okay, so that's easy. But notice that there's a p power here now. And what did I have on my last problem? What's the p power? Can you guess? It's a 1. It's a 1. So I have 1 diverges. Did you see that? 1 diverges. So for sure, right now, p equals, I'm just going to say p equals 1, that's going to diverge. Okay? For sure. So what my goal here is what numbers will converge? Are there anything else that can work to make this better? Like I already have one of the answers that won't work. So now what I want is the numbers that will work. Okay? And I'm going to go ahead and skip to the end. Nah, I'm not. I'm going to leave you in suspense. It'll be fun. So now we actually, for reals, have got to do the integral test, and it'll actually be a good thing for us. Now, I don't care about that 9. I think it's not going to change anything. And I'm going to switch to x's. And it's funny because we just did the integral of this guy last time, and so it's going to be a little different this time because we got that p power stuff. So my u is equal to ln x, du is equal to 1 over x dx, and again, we just saw this one. I mean, we just did it. And so what it ends up being is 1 over u now to the p power du. And so when I add 1 to the power, divide by the new power, what this actually looks like is a negative p power, right? A negative p power, and so then I can add 1 to the power, divide by the new power, go from x equals 2 to x equals infinity. Not at all concerned about the 2. So I'm going to flip this thing around a little bit. And so I actually have 1 over negative p plus 1 times 1 over ln of x, because that's my p, or that's my u, sorry, that's my u, all to the p minus 1 power in the bottom, from now 2 to infinity. So if I plug in the infinity into this guy, what am I going to get? And so let's see what we get indeed. Shouldn't I get ln of infinity is infinity? And then some kind of other number here minus some kind of number. I don't really care about that. I want this here, right here. I need this here. I need to converge. Because again, they're asking, when is it going to converge? I need this to converge somehow. And the best way I can see is to make this basically 1 over infinity makes a 0, and that will make a number in the end, or just 0 is fine, whatever. So I need to get 1 over infinity. As in, like, I need the infinity to have a 1 power. And so I need this infinity to the p minus 1 to be infinity to the 1. Solve for p. What you actually get here is 2. But the answer is not just 2, because what if I had infinity squared? Wouldn't that still go? What about infinity cubed? All these numbers are still going to work. So p equals 2, p equals 3, p equals 4, and all that stuff. These are all good. What doesn't work is the p equals 1, which, again, was the previous problem that doesn't work. So then I'm going to say 2 or more. That's my answer. And that is not good enough. Here's another thing that might kind of freak you out here. What if I had, it's p minus 1 business, what if I had 1.01 solve for p? I'm sorry, just infinity to the whatever. Sorry, I think I blew it there. Blah, blah, blah. What if I had a power that was 1.01? Yes. So I got infinity to the 0.01 or something like that. Well, that's still in the denominator, and it should still give me a 0, which is nice. And so that still will work. And so I'm saying that 1.01 will also work. And you can kind of see the pattern now. I got 2, 3, 4, 5, 10, 100, 1.01, 1.02, 1.0000001, but not 1.0, no way. So what's my final answer is going to be greater than 1. P is greater than 1. And I believe that you type it just like that. Actually, yeah, that's what I have in my notes. It says, that's the answer to type. That's what I have. So type that. Okay. Whew. Last question, and this one is a doozy. I don't want to do it because I'm lazy, but I have to because I'm the teacher. And I really don't like this problem, but we're going to get through it together. So they say, hey, does it converge or diverge? And yeah, guess what? It converges. P series, we're done, right? We're done. That was it. Wow, that was so awesome. No, they want every little piece along the way. They say, find S sub 10. In a sense here, this is part A. In a sense here, they're saying we're starting at 1 and we're going to 10, and they want you to plug those all in. That's right. So you need to plug in 1 to the 5th, 2 to the 5th, 3 to the 5th, all the way out to 10 to the 5th, add them all up, and you get a number. This number is actually super important for later, 1.036907. 6 is safe. 6 is safe. 6 decimal places is safe. That's your part A. Hang on to it. Part B, here we go. They say find your remainder at 10 is going to be less than or equal to the integral from 10 to infinity of these exact same thing. So basically, they just want you to do this integral here. That's a -5. So when I integrate, I'm adding 1 to the power, and I divide by that new power. And blah, blah, blah. You do some math here, and I got 0.0000025. Okay, so there's that. There's your part B. Awesome. Part C now says your Sn plus the remainder of n plus 1 f of x dx is less than the actual sum is less than s sub n plus the remainder at n. Oh my goodness, what are they doing now? So what they're saying here with this n and n plus 1, they're saying that this is the integral from 11 to infinity of 1 over x to the 5th dx. And this guy is integral of 10 to infinity, 1 over x to the 5th dx. You know what's funny is that you already got this number, 0.0000025. If you go and do the same math over here on this guy, you get 0.0001707. Okay, cool. So we got that. This Sn part is actually from part A, right there. This is Sn, right? Or S10, whatever. And so we already have those numbers as well. So I'm going to say my original part A answers 1.036907. 1.036907. You add them up, and you get two new numbers, 1.036924. Totally different number. And then 1.0369932. Wow, so different. And so your final summation should be between these two numbers. So that's how integral test kind of works with finding the actual answer. Though, when do we use this in reality? I don't know. Okay, that's all I've got. So thank you very much and have a great day.